Welcome. This video is on mixture word problems with percents. The basic percent of concentration equation. Percent of concentration times base amount of solution is equal to the partial amount of solution. You're probably familiar with this equation. Percent times base equals amount. The base is your total, the total quantity that you have. The percent, that's clear what a percent is. And the amount is the part. It's a partial amount of our total base. So P is percent, B is base, and A is amount. Find the quantity of fat in 128 ounces of milk that's 4% fat. And I know this isn't a mixture problem right now, but we're building up to our equation of a mixture problem. So just kind of be patient. Okay, so our percent, write down our information. Percent is 4%. Anytime you have a percent, you change it to a decimal by moving the decimal point over 2 places to the left. That's why it's 0.04. The base is 128 ounces. That's your total. And then the quantity of fat, that's our A. So that's a small portion of the 128 ounces of milk. So only part of it is fat. Not all of it's fat, just a part of it. Write down our equation. And our equation is percent times base equals amount. So 0.04 times 128. Either use a calculator or do some arithmetic on paper. Don't forget to move the decimal point over 2 places to the left in your answer. So our answer is 5.12. 2 places because the 0.04 has 2 numbers to the right of the decimal point. So the answer, the quantity of fat is 5.12 ounces. So in 1 gallon of milk, we have just over 5 ounces of fat. Okay, for mixture problems, here we go. We're mixing two quantities. Quantity 1 plus quantity 2 is our final quantity of the mixture. And here's our setup. First of all, we're going to write 3 circles, and that's to show that we have one quantity plus a second quantity is equal to our final quantity. And using the information from that previous formula, we're going to put our percents at the top, P1, P2, and Pm. Those are the percents of concentration of each. B1, B2, and Bt, those are your quantities of each. So the percent times your base, remember what percent times base is, that's the amount. So it's the amount of Q1 plus the amount of Q2 is equal to the amount in your final quantity. So here's our equation, and this is important. You multiply these two, add them, and that equals the product of these two over here. Okay, so percents at the top, amounts at the bottom, multiply each, and equals before the last one. Again, the circles, it's just a way to organize the data. Some people prefer a chart, and that's fine also, but I think the circles kind of shows you're physically adding 2 quantities together. We'll place the percents of the quantities at the top of the first 2 circles, and the order doesn't matter which one was first. This is what's important. The percent of the desired mixture will be in the final, the 3rd circle. And that percent will always be between the first 2 percents. So for example, if you mix a hamburger meat that's 5% fat with another that's 20% fat, the resulting mixture will be somewhere between the 2 percents. Maybe 17%. It depends on how much of each are used. If you use more of the 20%, it's going to be closer to the 20%. If you use a lot of the 5%, then it'll be closer to the 5%. So the range of this number will always be between these 2 numbers. Okay. When doing your homework or when doing examples, we're going to break it up into 3 different cases. So if you have these 3 cases to refer to, you'll be in good shape. Okay, here's case 1. Both quantities being mixed together are given 10 and 40. Let's say it's meat, 10 pounds and 40 pounds. How much are you going to have at the end if you mix two of these together? One's 10 pounds and one's 40 pounds. Right, 50 pounds. So for case 1, you add the two quantities given to get the final quantity. Case 2, only one quantity is given. So if they give us one of these, doesn't matter which one it is, then the other one has to be x, and we always add those two to get our final quantity, just like over here. 10 plus 40 equals 50. 10 plus x equals 10 plus x. So the second quantity would be x. To obtain the final quantity, add the two quantities in the first two circles for the final quantity. It's always a plus. Make sure you have a plus sign. Don't write 10x because that's multiplication, and we're adding these two quantities. Okay, so the first case, you add these two. Second case, you have to make one of them x, and then you add. Here in the third case, the final quantity is given. So for example, let's say it's 50. Let's kind of think of what can we write here. Well, x clearly could be one of them. If we're using two variables, you can use a y, but in this lesson we're not going to use a second letter. We're only going to do equations with one letter. So y is not being used right now. Okay, so let's make an example. Let's say this is 10. Well, what would this one be? Right, 40. We've been using those numbers. Let's say this is 20. Then what would this number be? If this one's 20, 20 plus what number would be 50? Right, 30. But using 50 and 20, how could you write this one? 50 minus 20. So what we're going to do, we're going to write that as 50 minus x. The quantity in one of the circles would be x, and the other would be total minus x. So if this is 100, this will be 100 minus x. Now, remember that subtraction is not commutative. Addition is commutative, so if you have x plus 10 up here, that's fine because x plus 10 is the same as 10 plus x. But subtraction is not commutative. X minus 50 is not the same as 50 minus x. So in case 3, when the final quantity is given, the first one's x, and the second one is a total minus x. If you reverse it and put the total minus x here and this one x, it would be fine. It doesn't matter which one it is. But one of them has to be x, and the other one has to be total minus x. Okay, you might want to make sure you write that on a note card or some page so that you can refer to it. Here we go. Here's our first example. How many gallons of a 15% acid solution must be mixed with 5 gallons of a 20% acid solution to make a 16% acid solution? Okay, well, I've drawn the three circles. Our percents are going to go at the top and amounts at the bottom. So we have a 15% and a 20% that we're adding together. And then we want to make a 16%. Yeah, that's going to go right here. And that's good because that final percent is in between the first two. So now our amounts. We have this 5 gallons. Does that 5 go with the 15% or with the 20%? So read it carefully. Sometimes you have to read these over and over to understand what they're saying here. 5 gallons of a 20%. So, right, it goes with this 20%. So now, do we have case 1, case 2, or case 3? Yes, case 2. This is case 2 because one of the numbers is given. So when one of the numbers is given, the other one that's not given is x. And then the final one, you add these two, and it's x plus 5 or 5 plus x, doesn't matter. We'll write that as x plus 5. Okay, see how referring back to our different cases is going to help us out here? Okay, now our equation. percent times your base plus the percent times the base equals percent times base. Now when you have a percent, you change it to a decimal, right? So 0.15x plus 0.20 times 5 equals 0.16 times x plus 5. Now, if we have that equation with decimals, one of the techniques that we have of getting rid of the decimals is by multiplying by a number like 100. If you multiply each of these by 100, that'll move the decimal point over 2 places. So if we do that, well gosh, look. It looks like the same thing as if we wouldn't have changed it to a decimal to begin with. So in the future, don't even bother changing these percents to decimals. This number times this number plus this number times this number equals this one times this one. Okay, so now multiply the 20 times 5 and distribute the 16. Okay. Move the 16x over to get x on one side. I blew that. I move the 100 over first, and then the 16. It could have been done in either order. So we get negative 1x equals negative 20, and then divide by negative 1 on both sides. X equals 20. Okay, so 20, that's our answer for the number of gallons at 15%. And that's all we were looking to find, how many gallons of a 15%. So the answer is 20 gallons of a 15% solution are needed. Okay, let's go on to our next example.